Welcome everybody to another episode of DevSecOps Live from Practical DevSecOps. This is a monthly event, and we're glad to have Izar today with us. Very thankful to Izar for having accepted our invitation in such a short notice. And for people that are typing messages in Zoom, continue to do that. Tell us where you're from and where you're attending this webinar from. And this is a monthly event, like I mentioned. So last time we did around the same topic, threat modeling, but with a tint of privacy. And we explored the Linden framework and then see how that could help us with privacy modeling. But threat modeling with code is particularly relevant to today's state of affairs with software security, product security in general, and with the movement of everything as code. Before we get into the meat of the topic, a few housekeeping items. The webinar is being recorded, so we will pass it on to our video editing and marketing team, and we'll get it up on our YouTube channel very soon, right after this webinar. And if you have any questions, put them in chat or use the Q&A section if you see that in your Zoom. Reserve them until the end of the session so we have more time, focused time to ask questions and have discussions around the topic. So today we have Izar with us. Apart from being a lead security architect at Lead Square, he's written a couple of books about threat modeling, but more importantly, authored this framework called pyTM that will help us threat model with code. Izar, over to you. I'm pretty sure you have an introduction slide about yourself, so
indeed,
take it over. Thank you very much.
So first of all, thank you for the invitation. It's really a pleasure and more being here talking about this stuff. I'm really passionate about threat modeling. Again, any questions in the middle, during, at the end, whatever, just put it in the chat, and we'll try to address that. About me, just one quick correction. I am right now the principal security architect at Squarespace, not at Square. It's a very common mistake that a lot of, even I in the beginning did. Now, one thing that you're going to notice in this presentation is that I really like to use animated lists in presenting. They help a lot. Some people don't like them, and I totally understand that. And in that case, I suggest you wait for the recording and watch in twice the normal speed, when my accent actually gets even more funny. So I've been doing the security thing for 20 plus years. I've been at Autodesk, at Dell EMC, RSA, IBM, a bunch of startups. Did the whole thing from top to bottom and bottom to top. Lately, I have co-authored with Matt Coles a book for O'Reilly called Threat Modeling, a practical guide for developer teams. And a lot of what we're going to see here is explained in depth in there. It's available on the Safari platform if you have access to that. And if not, in any of the number of places that you can get books nowadays. I am also a proud member of the Threat Modeling Manifesto group, where we're going to mention it a bit in this presentation as well. But here's the link if you would like to take a gander. So, oh yeah, the very important standard disclaimer. These are my views. They're not my employer. I don't speak for anybody that is not me. And sometimes Matt, I think. So what are we going to be talking about today? We are going to open up, well, of course, we're going to be talking about threat modeling. We are going to open up with a really quick intro. I'm very happy to hear that you guys have already seen last month the Linden framework. I am a huge fan of them, of that group at London University, and they put out not only Linden, but a lot of very interesting threat modeling work. I keep a keen eye on what comes out of there. Automation around threat modeling, of course. And we're going to close with a look at the OWASP pyTM, what it can do, what it can't do, how to use it, and so on and so forth. And then I hope I'm going to have your questions. So first of all, let's level the playground. What is the security thing that we spend so much time and effort looking at? So basically in the beginning, we have this system thing, right? It's something, it's a bunch of bytes running on some kind of iron with a lot of blinking lights coming out of it and stuff happening. It holds some data, and together with that data, it offers some kind of functionality. So in this yellow square, basically, we have the reason why we wake up in the morning and go to work. We want to be able to store, create, and transform data, and offer that as a functionality to customers, and thus generate some value. Now, that's the good side. That's when everything goes according to plan. What could go wrong? Well, sometimes those systems have weaknesses, right? And those weaknesses, they can turn into vulnerabilities if they can be exploited in order to either stop the functionality or to access the data and things like that. And that gives a threat actor, somebody who has some ill intent towards us and our systems and our data, gives them an opportunity to exercise a threat through a vulnerability. And in this way, generate risk to that value, and with the risk, a possible impact to that value. So threat modeling is, according to the threat modeling manifesto, analyzing representations of a system to highlight concerns about security and privacy characteristics. Now, we spent a lot of time trying to come up with this definition. We noticed at the beginning that something like 15 people who lived and breathed threat modeling, each one of us basically had a different definition of what threat modeling is, of what the process is, of what we get out of it. Everybody has sort of a different idea of the same thing. So we came up with this very concise definition, which basically embraced what everybody thought at the time, thinks at the time, right? So the important things to take away here is that we are talking about representations, plural, not only one, like many different ways of representing a system. And that we are trying to bring about to highlight any concerns that we may have, not only about the security, but also the privacy. Again, referring to your last talk about Lyndon, threat modeling for privacy is pretty new. It's something that perhaps we did, I don't know, as part of the whole overview of the thing a while ago, but today it becomes more and more and more important. But basically what this boils down to is that once you have a system model and you use it to do some threat analysis, what you get at the end of the day is a threat model. So it's a two-part, I won't call it process, but it's a two-artifact thing that gives birth to another thing. And the reason why I use the word thing, we're going to see soon, is that it can also get expressed in many, many different ways. So it's not only a different representation of the system, but it's also different possible representations of the threat model itself. And according to the threat modeling manifesto, at the end of the day, what we want to do here is to extract some kind of value for the security practitioner, right? This is a threat modeling. It's a process that can take time, can take resources away from development, can take people away from development. And many places are still a bit reluctant to embark into it because they consider it a high investment, low return process. And at the threat modeling manifesto, what we wanted to bring out was that once you find the way that works for you to do it and for your organization, the important thing is that you bring about value with it. So if what you're doing doesn't ultimately offer you any kind of added value to your security, then you're probably not doing it right, or you probably have some things to change. But at the end of the day, those representations, that analysis, that threat model has to be something that is advantageous to you as a security practitioner and to your organization as an organization interested in security. So the first part of the thing, modeling. How do we model systems? The interesting thing about working on pyTM was that it opened a door, it opened an opportunity to stop thinking in terms of a DFD and think about other ways that people would like to represent, to model their systems. Basically, what we want here is to be able to gather all the people who are interested in a specific system and in some way reach a way that everybody looks at the system and sees the same thing. Many times I went into a threat modeling session, and the impression that came out was that basically we had a lot of people talking about the same thing, but each one had a different view. Matt and I play with it that we call this the blind man and the elephant allegory. It's the very famous story of some blind men that were asked to describe an elephant, and each one of them touched a certain part of it and started describing the trunk or the legs or the tail, and each one of them thought that this is the whole elephant, but actually, as we know, it's not. So the same thing when people threat model, when they are not exactly in sync or they're not seeing the same thing, and each one comes up with a different view. Or what we call the eureka moment. You have the traditional threat modeling session, and the big architect is in front of everybody in the whiteboard, and he's drawing in the board and saying, this is how the system works. And then you have some junior developer that raises his hand and says, you know what, that's how it was designed to, but when we started implementing, there were some problems and we had to change it a bit. So this is how it actually works. So as you go describing the system, it turns out that there are details that have to be changed and that there are assumptions that were made that might not exactly be one-to-one relationships with reality. And unfortunately, those are the details, and that's where the risk resides, right? Because when people are speaking different terms about the same thing, and each one of them thinks that their representation is the right one, that's when things start falling through the cracks. Now, with all that big preamble, basically what I mean is that the simplest, most popular form of modeling a system is by making a diagram of it, right? So we say, hey, we have a group of processes here. It's a circle inside a circle. That's the accepted symbol for group of processes. And this one happens to be a web server. It happens to authenticate users. It exposes only HTTPS, and it's running on the front-end server, right? So here we basically know all we need to know to make a basic set of assumptions about this process, about the system that it resides in, and that actually have security value. But these things, they don't live in a bubble. They don't work alone. It's very rare, the system that, if it exists at all, the system that exists without interfacing with anything, right? So here we have a process B, and this one is a single process, it's a single circle, and it is a database server. It exposes port 1521. Those that know already have a hint about which database server it is, or it might be, right? It's been written in Java. It runs on the backend server, and it runs privileged. So we have a different set of information about that process that offers a different amount of security valued data that we can use to make inferences about the process. And that data has to be stored somewhere. So there's this data store out there. It is XML based. It's not encrypted. And basically everybody can write it, and some people can read it. Now, these are three different parts of the system. And again, alone, they don't do much. But once they start talking to each other, once we start modeling the data flows, the ways that the data goes from one part of the system to another, then we start extracting even more value, security value from that modeling. So now we know that between the front end and the back end, we have an ODBC SQL query going on, and that username and password pass over there, and there's a session token coming back. Same thing with the database, with the data store, what it reads, what it writes. So this is basically, once we have this, we have enough information to say, hey, I understand the system. I might not know what it does. I don't know what content gets served over HTTPS. But at this time, at this level, that's probably not very important. But we have enough information to say, hey, you know what? I understand the system. I'm able to answer questions about the architecture of the system. Once we have that representation, or one representation, then we pass to the analysis stage, right? And this is where the threat modeling, the diverse threat modeling methodologies come into play. Most of you, I'm guessing, have already heard about STRIDE. You look at the impacts that come through spoofing, tampering, repudiation, information disclosure, denial of service, escalation of privilege. You have to basically look at your representation and say, oh, looks like this element on STRIDE per element, looks like this element has a problem with spoofing, and it happens this way and that way. It doesn't authenticate. I can't guarantee that whomever is talking to it is actually who they say they are, and so on and so forth. So this one is security focused. As you seen last month, Linda, basically the same approach, but now we are looking at privacy impacts. Then you have, dear and closest to my heart, CTM, continuous threat modeling, where basically you are taking a fundamentals approach to how threats get introduced in a system. So basically you have a baseline threat model, and then you threat model every story. And you use if this then that list for developers themselves to figure out what are the threats that they're introducing to the system and how to remediate them. And these all start with a model to analyze. So apart perhaps from CTM, which can start from zero, but Stride and Lindum sort of require you to at least have an idea of what is it that you are building. You have that representation, you have that DFD, that data flow diagram, and you are able to refer to it so that you understand what is it that we are building. Remember the 4 questions of Adam Shostak of the Threat Modeling Manifesto. First one, what are we building? So that's in heavy part the modeling. The second, what can go wrong? Which is, again, heavy part the analysis. What can we do about it? The remediation of those findings. And then in fourth, once you finish that round of the process, did we do a good job and how do we improve on the next one, right? And then we have Tara, which is less based on a model to analyze, and it's more focused on, it's a spreadsheet-based approach, and it's more focused on the assets and whatever tactics a possible adversary could use, or you could say that it's attack-focused. So we have the modeling and we have the analysis. Now, just a parenthesis, I've been talking about the Threat Modeling Manifesto a lot, a bit more about what it is. We had a working group of 15 very experienced threat modeling practitioners, theorists, and people from academia. We came out with that definition and 5 values and 4 principles that we think represent the things that should appear in a threat modeling process, the things that should guide the threat modeling process. And we identified 5 positive patterns that help you lead your threat modeling process and 4 anti-patterns that hamper that process. And it's completely methodology agnostic. We do not say use this methodology and not that one. We don't point at tools. We just look at the threat modeling process itself, at the value of the process itself and what it could bring to you. And I like to suggest it as a good first stop to people who are just starting to bring threat modeling into their practice or into their organization, just so that they can start from a good place in terms of where do I want to be? What is it that I want to extract from this journey called threat modeling, right? So now we know what the playground looks like. We know what modeling looks like. We know what analysis looks like. We have a good place to start the whole process. So now let's talk a bit about automation and pyTM. So there's a lot of threat modeling tools out there, and most of them are really, really good for what they set out to do. One very good thing is that the number of approaches that we have in those tools, they are not copies one of the other. They have similarities, of course, because we are talking about tools that do one thing. They do threat modeling, but they are by no means similar to the point that you would have, I guess, you would have difficulties choosing between them. But the important thing is that they offer a lot of variety in terms of how you approach this thing called automated threat modeling, right? So you have those that are diagram based. You go and you draw your diagram. You have some that are based on questionnaires, and they are mature and they give great results. But the thing is that at some point, Matt and I were talking years and years and years ago when we worked together at the WMC. And when you're working with Matt, one thing that you hear a lot is, wouldn't it be cool if? And a lot of those conversations went about, wouldn't it be cool if there was some tool that developers could use to threat model, or to create a threat model, or to create a baseline for a threat model that didn't involve that loop of drag and drop and arrows linking to points and pressing a button and getting an amazing, extensive list of everything that could possibly go wrong with a system as modeled, but that weren't as relevant to it as we would like to. And back at that time, one of the most popular, if not the most popular tools available was the Microsoft Threat Modeling tool, which by itself is a great tool, no two words about it. But it is focused on Microsoft systems, Microsoft Windows-based systems, and Azure now. And that already orients a lot of the attributes of each element that you are asked to fill. But that you definitely can use, and people do use it every day, to model generic systems and get a lot of work, a lot of value out of it. But at that time, it was basically one of the, if not the one free one that was available. And we were having problems because, first of all, a lot of developers did not feel like starting with a diagram was the right way for them. They wanted a bit more flexibility. They wanted something that wouldn't take them out of the place where they were when they were in the system, when they were designing, when they were working. And a lot of them did not work in a Windows environment. And the threat modeling tool by Microsoft is a Windows tool. So you would have to have some form of Windows operating system to work it. And we had a lot of people that worked on Unix and Macs and whatnot. So we started thinking, what can we do that does not involve dragging and dropping things in a canvas, right? So we came up with pyTM. We wanted something that would let you express your system as elements in code and the attributes of those code, of that element. So basically, if you think about those circles and squares and arrows that we put on diagrams, each one of them represents one thing. And that thing has values, has attributes. As you saw in the modeling slide, the port where the thing runs, the language that it was written in, the kind of data that goes over the data flow, the kind of data that gets stored somewhere. All of these can be expressed just as attributes of an object. we wanted something that would generate at least baseline threats, meaning garbage in, garbage out. As a function of what you put into your modeling, you would get a list of possible threats that would actually bring value to that modeling. We wanted to get diagrams out of it because even though developers were complaining that, hey, you know what, I can't stop what I'm doing to draw a diagram. As a byproduct, it would be great to have it because A, there are some very visual people working in the field that really extract value from being able to see a diagram. And B, to reach that consensus of, yes, we are talking about the same thing, it helps to move from one representation to another and see if things hold. It's easier to show people a diagram on a slide and say, is this really what we're building? Then have them read lines of code and say, is this what we're building? Especially because you want to get the input from those people who are not exactly developers per se, product managers, program managers, QA people who are not involved in the immediate design and implementation of a system. Different representations are going to let you move between them and make sure that you are getting the input from everywhere until you have a good representation of the system that you're working on. We wanted to get a report, something that you could hand to someone and say, hey, here's the inherent risk of the system. Here are the findings. Here are the details on those findings and the things that we have to do in order to fix them. And we wanted the threat model and the code that it represents to live and to evolve together. So that's when people started using Git for everything. And we said, hey, wouldn't it be cool if we had parts of the system represented together with the code that's actually representing, right? So this is how pyTM started. Now, the team that started it, of course, Matt and I started it, and we were joined by Nick Osmore and Rohit Shamhuni. And once it went open source, we were very fortunate to have John Wass jump in and help a lot in making the code better, because tell you the truth, none of the four of us are full-time developers. And it was great to have somebody who actually understood what was going on and was able to point to us better ways of doing things. So the making of pyTM basically is very, very simple. We came up with a very simple schema that's so far being able to abstract most systems out there. So we have things like a data store element, we have a server, a client, a data flow. Lately, we have introduced data elements. I'll talk a bit more about it later. And each one of them with different sets of attributes. That some of them are common, some of them are specific to the kind of element. And we feel that even though there is space to grow, with the set that exists right now, we are able to express most systems that we have encountered. On top of those elements, we have a set of rules. Now, the rules write to pyTM 1.x, they are actually Python Boolean expressions that at the end of the day return true or false, and they express a possible vulnerability. So for example, the first one here, the finding F1, it only says that if the target, the thing that we are looking at, is a process, and it runs with root privileges, and it exposes something at all, then, hey, we have something here that we might want to look at a bit better. The second one says, hey, if you are exposing port 80 and the data that's coming from there is HCI, then you might want to look at that a bit better, a bit deeper. And then we have a loader to be able to reuse previous definitions. We have a parser that breaks up everything into neat structures that we can go through. An analyzer that actually runs the rules over that set of data, and a render reporter engine that uses a very basic template language to generate reports and to generate the diagrams and all that good stuff. So how does the big loop work? You start by defining your components and the relationships, the data flows between them, as objects. Then you can generate a data flow diagram or a sequence diagram or both. We're going to see the differences. You annotate the components with the attributes, those values that are unique to each element. What protocol is running over a data flow, what's the classification of the data running in there, what operating system is your server, has it been hardened or not, things like that. And then you generate a report that brings everything together in whichever format you want, and move from there. Fix your stuff, then go back to the beginning. This here is the simplest possible pyTM script. You start, of course, by invoking Python. You import from pyTM those objects that you are going to use. The only one that's actually mandatory is the TM, which is the threat model structure that holds everything together. You initialize it with some generic name, and you define your whole model in between. And at the end, you just call tm.process. That's enough to get the whole thing running. So what can happen in the place of those ellipses, those three dots there? You would start, oh, I always forget that I did this with squares. So you would start by defining your elements. So here we define 4 of them: one actor, one process, one server, and one data store. We give them names that we can recognize when they get referenced. And you see that this falls squarely between the definition of the TM structure, the TM object, and the call to the process function. Now, this is not enough. As we said, elements cannot live by themselves and give us any kind of value to what we want. So we start defining what is the data flows between them. So here we learn that between the user and the client, you have the customer assessing the system, and we call that the interact data flow. And so on and so forth between the client server, the server and the database, until we have modeled all the possible data flows in there. Now, one interesting thing, this slide is a bit dated. Nowadays, you can, instead of the name of the data flow, you can directly specify which data object goes in there, because we realize that many different kinds of data could flow over one given data flow. So now we have the opportunity of specifying those different data, each one of their classification. Then the classification of the data flow itself becomes the maximum value of the classification of all the data that goes through it, and so on and so forth. So now we have the elements, we have the ways that they talk to each other. But what that generates is this very simple DFD and sequence diagram. Now, by themselves, they start having some value. How? You can look at them and you can recognize your system. You can start recognizing your system. So you can make, you can fix assumptions in here. You can add, remove data flows. And by itself, they already offer some value, especially for those people who don't like to drag and drop stuff, and also for keeping things versioned together with code. But what we're missing here is the security value, the threat value. So how do we start getting that? One way is by defining trust boundaries. We are very interested in knowing when the trust changes between the elements, which data flows straddle trust boundaries and have different trust values on one side of them than the other. So here we add 2 boundaries. one that is public, it's uncontrolled by us, and one that is protected, it's controlled by us. And then we start assigning to each element in which boundary it lives. So the user and the client live in the public boundary, and the server and the database in the protected boundary. What that does, it expresses those boundaries already in the DFD. Of course, you won't see that as clearly in the sequence diagram. But now you start having a more focused idea of what's important, what is it that we have to put more focus on protecting, and where are the weak links where things can go wrong. And now we move to actually annotating each one of the elements and giving it the specific attributes that they would have. So here, for example, the call out in red says that the max classification of the database is restricted. So in a normal data classification scale, you would have public, sensitive, restricted, secret, top secret. What the max classification attribute says is that, hey, if I get any data flow that is adding data above restricted to this database, flag that as a threat, because this database is not supposed to be holding anything that's above restricted. Another example here would be if the database is SQL. So you can imagine that that would lead to a rule saying, hey, if it's not SQL, then I probably don't have a SQL injection threat in there. So I don't have to flag, I don't have to say anything. One common attribute that we have here is the in scope. If it's true or false. If it's true, then that element is going to be taken into account when evaluating rules. And if it's not, it's going to appear in the representations, but it's not going to be evaluated. So that helps us model the system in full, but express sorry, I lost my train of thought. Express the system in full, but express the findings without without using all the elements that we supported. I have to close the chat because I just jumped into it and got booked. Okay. Now, how do we get the reports out? We have this very simple template language that uses the Python elements themselves, the Python objects themselves, and their attributes. You can see an example here of how Markdown, I think this is Markdown. Yeah, how Markdown template gets expressed. We get a loop here of the items, then the targeted elements, and each one of their severity, and so on and so forth. Now, what that looks like at the end is this. So pyTM already comes with a sample, actually two sample templates, one simple, one advanced. This one, if I'm not mistaken, is the simple one. And it tries to put everything together. The data flow diagram at the top, the dictionary of data flows, and the dictionary of data that goes on the system. And here at the bottom, we have the potential threats. You see each one of them has a triangle. So because this is HTML, it just means that they are closed. And I believe that once we open each one of them, what you get is first the targeted element. So you see there client/GUI. And you can immediately refer to that second circle there. So we know which element that threat refers to. And if we go back here, we see that it was that process that was represented as a client. So it's very easy to relate each threat to what it represents, both visually and back into code. The severity right now is fixed. It's a common severity for that class of threat. We get a lot of information back from KPAC, from the CWE, from the ATAC framework. So we reference all those here in the bottom. We suggest mitigation. What can you do for that kind of threat? And and the example instance, meaning it's important to be able to tell the story of that threat. The threats don't exist in a vacuum. Not only that, but just looking at the CVSS or at the severity that we given here doesn't tell the whole story. By giving you an example instance, we help people start building the story around that specific threat for their system and decide if the severity is actually the right severity for them, or if they already have mitigations, think difference in depth. If they already have mitigations in place that lower or in some cases bring up the severity of that specific threat. The fun thing about PyTM is that it's basically a Python library. So there isn't one PyTM program that you run and everything happens. You write your script, you have the import in the beginning and the TM process at the end, and that script becomes the thing itself. So the way to invoke it is by running your script with any of the arguments that PyTM has. So you can, for example, dump all the elements into a SQLite database, so that people, it was one form that we found in the beginning, that people could take the stuff that came out of PyTM and bring it to other systems, import it into other systems and manipulate it over there. You can decide if you're going to do a DFD or a sequential diagram on the command line. You can do the report, of course, by naming the template that you're going to use. You can exclude some threat IDs. Each one of the threats in pyTM lives in a JSON file, and they have unique identifiers. And you can decide that some of those threats are not relevant to you, and you want to exclude them altogether. So you can put it on the command line and never see them again. We have a flag that gives you a list of all available threats. Available threats does not mean the threats in the model. It means all the threats that pyTM knows about. So this way people can start building their own threat library and using it as they want. Sometimes it's useful to know what possible attributes a given element could have. So we have the describe element that lists those attributes. Lately, we can output a JSON file with all the findings and all the information that pyTM has internally. We are moving towards producing output in the OTM format, the Open Threat Model format. And we hope to have that out soon. Levels is an interesting one. If you think in terms of building a system and representing the infrastructure, representing the processes, then representing the business process on top of it, you could say that each one of them is a different level. And if you were to draw them together, you would either use different diagrams or you would overlap one diagram on top of the other, things, stencils. And the levels capability lets you tell each element to which levels it belongs, and then express diagrams containing only those specific levels. And stale days is one that I really like. You can specify on the element itself where is the source code that actually implements it. And then what the stale days will do is it will compare the date when the threat model script was last modified with the date when that source code was last modified. And if it goes longer than a certain delta, it's going to alert you and say, hey, perhaps you want to check if your threat model still corresponds to the thing that got implemented, right? So that's a new capability that we have been testing lately. To create a DFD, you just call the script here with --DFD, run it through dot. Now, pyTM doesn't try to do everything. pyTM has absolutely no idea how to draw an actual diagram. Turns out that turning a specification into a diagram is a really, really hard problem. because you have to calculate layouts and things that don't overlap. And even there, after a certain number of elements, things get very, very confusing and very, very hard. So we delegate the creation of the actual diagram to the dot suite of programs. Same thing with the sequence diagram. You call it with --seq, and it goes into plant.uml. And that creates the sequence diagram that you can go to. Same thing with reports. We can create a Markdown, for example, or we can create anything that the templates that you are using actually defines. So any text-based format is actually something that you can create from pyTM. But if you want a different format, we ourselves use Pandoc, but there's a number of different translators that you can use. Sorry. And thus create whatever report format you want. So it's on GitHub. We are an OS Incubator project. You don't need any previous experience in Python or anything. Just jump in, open something on issues, start talking to us. We got lots of work to do. We got a lot of good first issues on GitHub if you don't know where to begin or if you want a pointer. We have a very supportive developer and user community. They are not huge, but they are very passionate. We have a Slack channel. We have a mailing list that we almost don't use, but the Slack channel is open and anybody can join. No idea is too crazy. If you have something here that you think should be different or should be added, come and talk to us. We are ready to think about anything with you. With that said, any questions? Now I can open the chat and hopefully that won't derail me. Okay. Very cool to load the JSON into a graph database. Has anyone done that? No, but it's an interesting question. Yeah, that would be something that we would love to talk about. Can we apply the C4 model using this approach? So I am not really very conversant in the C4 model. I have seen it before. I have read some about it. I haven't used or approached it in any formal way. But I think that it's probably easy to create a relationship between the internal schema and what C4 asks for. A lot of my threat models don't have all the elements, missing data storage, CI. Will pyTM work then? It will. But again, it goes into the quality of what you put in is the quality of what you get out. So you're probably going to get less threats than possibly exist in the system. The good thing about a pyTM is that it would be very easy for you to put some dummy stuff in there and then take it out if it's not what you actually wanted. Oh, this is a great question. We are relatively new to threat modeling. How can you recommend to start with pyTM? So the thing is, I would say that pyTM could help you both in creating the model and in getting a baseline of threats. I would suggest that you look at pyTM together with a methodology that would work for you and your team. It's very important to be able to step out of the tool and into the loop of thinking about these things and saying, hey, there's more stuff in here than the tool could give me. The tool will give you the first leg up, the place to start from, but you should definitely not limit yourself to that. So it's a good start. It's as good a start as any other tool, as long as that works for you, as long as you don't have to change the way that you work to fit the tool, right? So don't let the tool dictate the way that you're going to work. Find what works for you and get a tool that supports that. That's my personal approach to it. what is fed as input to pyTM code? Yes, you basically write Python code, but to tell you the truth, we haven't had any problems with any developer that knows basic object-oriented language, like object.attribute equals value. So people who have, JavaScript, C++ experience, anything like that, they immediately are able to use pyTM because there's basically no logic, no crazy Python structure in there. Not that you couldn't. I've seen some pretty interesting and ingenious uses of pyTM that had some very hard logic in the script, but you don't have to. Most challenging part of integrating threat modeling from scratch in an organization? Oh, that's an amazing question. So I would say that the most challenging part is the initial bump of showing people that there is value in that. Threat modeling as an activity has a cost. It costs time, it costs brain power. And if people cannot immediately see that it has some kind of value, they are very quick going to either drop it or they are going to turn it into a compliance activity, meaning they are going to do the threat model just because somebody told them that the system has to have a threat model, and that thing is going to go into the desk drawer and never come out. And that, again, goes back to the threat modeling manifesto to if the thing doesn't have value for you, then it's probably happening wrong. So I would say that the most challenging part is to convince people that there is value in there. If I want to incorporate this into my team, ideally, who should be responsible or take up this, as this would be an additional workload for the dev? Yeah. So threat modeling is a team sport. Remember when in the beginning I said I spoke about the parable of the blind man and the elephant. We cannot fall into the trap of saying we have a hero threat modeler, the person who's responsible for threat modeling for this team, for this project, or for this system, and they are the ones that know everything, because they will not know everything. Rare is the case when anybody knows anything, everything. So make the activity from the beginning be a team activity. Include it in your definition of done if you are doing an agile process. Include it in design meetings if you are doing something a bit more waterfalling. And again, everybody, if you adopt my approach, the CTM approach, every developer is going to be responsible for whatever they put into the system. Every developer is going to be responsible for threat modeling every story. So that brings the accountability for the threat model down to the threat model, to the developer level. Okay. I think that we are almost at time. Any other questions? Okay, so pyTM does not use stride, and we already referenced the MITRE ATT&CK framework. So that's already in there. We do have some references. How would you justify the extra value that brings TM over simple ASVS mapping? In other words, in the traditional system requirements plus ASVS, what TM could bring? Miguel, you got some really, really good questions. So I would say that the extra value in here happens at a bunch of levels. The first one for me is those eureka moments. When we start talking modeling, we start talking design, and we discover that the system is not exactly what we thought it was, and some things changed through time. The second one is when you step away from threat modeling being a dry thing, like the pyTM rules show. Like if you have an SQL database, then you probably have SQL injection threat, and you jump up one level to threat modeling your business processes, to threat modeling your privacy. So if you have a process where you have a data flow where email is created, and you start asking yourself, hey, is an opportunity here for spamming? Can people use this implementation to use me as a spam gateway, for example? So that's something that you cannot exactly derive from dry rules in an element. You could, but you would need that jump in imagination to bring you to the next level. And that's where I think that the actual big value of threat modeling is. When you step out of the boundaries of a very dry and defined system, and you can think at higher levels. And that's where I think that the tools actually give us a lot of value, because they free us from the baseline low-hanging fruit stuff and bring us to the higher level thought of processes and how things interact at a less formalized level. What is the added value of pyTM over existing commercial offerings? Look, I don't like to say added value, because that would mean that pyTM somehow is better than the commercial offerings. It's not, it's different. It's a different approach, right? So to this day, I am not aware of any commercial offering that can offer threat modeling with code. pyTM can. So if your team likes that, if your team likes the proposal of what pyTM brings to the table, then it's a good place to start. Plus, you know what? It's free. How to threat model for a shared environment. Part of infra lies on AWS and a part lies on-prem. The methodology remains absolutely the same. You just have different trust boundaries in that case. Do you apply different standards to the same model? Stride plus Dread? Yeah, Dread. Walk away from Dread. Dread is dead. But those wouldn't be standards, actually. Those would be different frameworks, right? And again, I would say you use the framework that's more appropriate to your system, to your team, to your organization. And sometimes you're going to come up with yours. You're going to say, hey, you know what? I'm just interested in this amount of things, in this quality of things, in this number of things. And you end up developing your own framework. So everything is good. You go after what works for you, what brings value to your effort.
Izar, thank you for answering those. There's a few on the Q&A section. One of them is asked here. I will ask the other one. When you showed attributes that belong to a certain element, like a data store, there were attributes like classification and then server and other details. The question is how these attributes are managed on DB instances like RDS, AWS. And I asked for additional information, and I think this has to do with if those database instances on the cloud have specific properties, can they be added as custom properties of sorts within that data store element? I'm making this assumption on the question that was asked because it's not very clear. Sorry about that.
That's the beauty of Python. You can add attributes as you want, and the inherited beauty of pyTM is that you can very easily figure out your own rules. So if something being somewhere specific might express a given threat for you and you want to include that into pyTM, it's one text file away, right? Now, of course, we won't have rules for everything under the sun. And that's one of the reasons why we have now loadable sets of rules. So if people want to create their own sets of rules specific to certain environments and PR them into pyTM, we're going to love that. But to answer the question, you can definitely use your own attributes, and you can develop rules according to them.
And what I have another question. The last time I looked at, there were about 110 rules to generate threats in pyTM. What is the recent number there?
Well, we inherited a lot from KPAC and actually from the threat modeling tool by Microsoft. And I think that at some point we moved the focus a bit more to the framework and less to the number of rules that we had. But again, it's very easy to add. So at some point we're going to go back and add some more.
Super. One last question from an implementation perspective. Don't want to hold you here for too long. There has been too many questions already, and you've been very patient and kind. How does someone typically write threat modelers code? Do they picture some things on a whiteboard, those circles that you mentioned, those boxes that you mentioned in a whiteboard, and then Or think about that mentally and then write, this is my element, this is my attribute. How does that process normally look like?
I guess that if we go towards that kind of resolution, I think that we have as many processes as we have people. I mean, everybody's definitely going to do their own thing, right? I have seen threat models that started on the back of a napkin, and I have seen threat models that started on volumes of formal documents describing a system. So once upon a time, I was involved in a given system that was developed using a very precise and formal, it was a military system, it was very precise and formal process. So even before one line of code was written, there were like volumes and volumes and volumes describing from the UI to the interfacing of the different parts. And it was pretty easy to threat model that because you basically had already the system described in that formal way, right? But I have seen people just like on the back of a napkin, drawing bubbles in the air and saying, hey, this thing connects to that thing. How could this go wrong, right? Any other question? Hello?
There's one last from Miguel. Why don't you like Dread, right? It's not why don't you recommend Dread, it's why don't you like Dread? What do you recommend to assess risks or threats? And that would be the last.
It's not that I don't like Dread. I don't think that over time, apart from very, very specific cases and environments, Dread has been very successful simply for being a bit too subjective, right? It's for me, for other people that I spoke with, it's at times made things difficult to compare. And what's the use of having a list of threats if you can't really figure out what to do first, right? And some people are definitely more successful using Dread, and great for them. I'm happy. In my experience, I have not been that successful with it. And in terms of what to use to assess the risk, to rank the risk, my personal choice is CVSS plus story, meaning, yes, get the CVSS raw score, but then tell the story of the vulnerability as it fits your environment, right? Because again, an SQL injection on one environment is going to be a completely different risk from an SQL injection in a different environment. Some of them take the internal threat much higher than others. So in certain circumstances, that changes the risk of the same vulnerability to one side or to the other. So I personally use a risk-based approach where I say, hey, this is the vulnerability. This is how it gets expressed in our system. And here's what I think the risk is, right? And based on that, then a decision is made on how to address that. Does that answer your question, Miguel? Man down.
Well, it certainly does, Izar, at least from my perspective. We are running out of time, but I want to thank you very much. The presentation had a dark theme, so it was very easy to look at, easy on the eyes. Slides were clean, reminded me of the clean code book from Uncle Bob, very clean. Also, the presentation was lucid, eloquent, down to earth, and down to the point. Thank you very much. It was very brilliant.
Thank you.
And also the participants, thank you for those excellent questions that we had. It was a very interactive session towards the very end. Izar, finally, thank you very much for your contributions towards the threat modeling community. Look for more collaborations and more innovations from all of those leaders that you've listed on the resources. Thank you very much for your time today. And everybody else, thank you very much for tuning in today. We're going to do this every month. There are other topics on the area of threat modeling and DevSecOps in general that are coming up. Stay tuned for our LinkedIn pages. Thank you very much, Izar. Great to have you here. Have a great day.
Thanks, everyone. It was great being here.